All right, it's time for a super quick homework hint on the problem where the student on a skateboard tosses their book into the air. And then we want to figure out how fast the skater is moving after that. Hopefully the book that they're throwing into the air is from some other class and not their physics textbook, because we all love physics. So the important thing to remember here is that momentum is a vector, which means it can have both x and y components. So you're given how fast the masses of both objects, and then how fast the book is thrown, and the angle at which it's thrown into the air. Now, because everything starts at rest, we know that the total momentum of the system begins at 0, and therefore it must also be 0 after the book is thrown. Right? That's our collision in this problem. So as we look at this picture here illustrating the two momentums, we can see that so if the book is thrown, say, up and forward into the air, we know that the skater has to move horizontally, so the skater would move backward. Right, so if we look at momentum as a vector, we know that both the x component and the y component have to be 0. So the x component of this of the book momentum is going to be completely offset by the momentum of the skater. But the question then goes on to ask, what momentum is transferred to the earth? And the reason why that's a reasonable question to ask is because this book momentum has a y component, and there's nothing from the momentum of the skater to cancel that out. So that y momentum has to be canceled out by something, and it turns out that that momentum is gained by the earth. So the earth is going to have some downward momentum in order to cancel out the upward momentum of the book and make the total momentum 0. Now, of course, this momentum compared to the mass of the earth is going to be small. So the problem only asks for the momentum that the earth receives from this interaction. If you took that answer and divided by the mass of the earth, which is huge, you would see that the earth has a very small change in velocity from this procedure, which makes sense with what we expect, that the earth really doesn't move just because you tossed a book into the air. So the important thing to remember about this problem is that momentum is a vector, and therefore both the x and y components separately have to be conserved.